Hello, everyone. We are a group of students from NTHU's PME Programming Design offered in 2023 fall semester. Today, we are going to present to you about our project this semester, which is elastic bouncing ball animation using Qt framework and C++. So we will divide this presentation to six sections, which is overview, physics concept, ball widget class, main functionality, and also conclusion. First of all, we have the overview. Our goal is to create a graphical simulation of a bouncing ball that allows users to control the animation and explore different materials affecting its bounce behavior accordingly with the COR of each material. We use Qt framework to make the animation for this simulation. First of all, the physics concept behind this simulation would be the coefficient of restitution's formula, which is the absolute value of bouncing velocity and the initial velocity. It can also be denoted as the square root of the ratio of the height of the bounce and also the height of the initial state. So this is what we get from those fundamental formulas. And to be honest, we only use this one because we denote the height and position as a function of the velocity, which is also affected by the gravity. So the user inputs the initial height and initial velocity, and from those values, we can get the bounce height, bounce velocity from the coefficient of restitution from a lot of materials. The data is stored into a text file so that the program will read the coefficient of restitution text file. In our code, the formula of the COR will be denoted like this. So the velocity increases accordingly with the gravity, and the position decreases when velocity becomes bigger, which means it's going nearer and nearer to the ground. And whenever this argument happens, it means that the ball will be on the ground. And whenever the ball is on the ground, we change the velocity, we multiply it with negative e, which means that it will become slower, well, mostly for COR less than 1, and it will change direction because it's multiplied by negative 1. After the velocity changes, we refresh and we reset the position to 0. These are the libraries we used for this animation. So as you can see here, most of them are just essential headers that Qt framework provides us that can be used with C++ as well. From the ball widget class, this ball widget class is the most important of our project. It is basically a derived class of Qt widget and also from the Qt environment. It manages the ball animation from user interface. The class consists of member functions and member variables as well as constructors that are very important for creating the falling ball widget. As we can see here, the Q combo box, Q push button, and also the Q plain text edit is basically from the Qt environment. The ball widget class is divided into 7 parts. Um, Paint event basically drawing the ball in the ground. To float is basically changing string input, converting it into float. Initialize combo box is to set up a combo box, and animate to update the ball position. Start, stop, and reset according to the user, and also change material according to the COR.
So here is the constructor of our uh, ball widget class. And in this constructor, we first initialize the combo box, which contains the materials of the ball with different COR values. And next, create the start button, and we assign a position to the start button. We then connect the button to the start animation function, which is basically a function to start a timer to control the animation. And the next button is a stop button, which is connected to the stop animation function. The stop animation function is basically also a function to stop the timer. And there's also a reset button, which resets the ball based reset the ball and redraws the ball based on the input by the user. Next, in the constructor, we also create the timer. with a time interval of 16 milliseconds. And we also assigned the COR, which is 1.79, since it is the first choice of material, which is silicon, in our combo box. And we also create a plain text edit, which is used to input the radius, the initial height, initial velocity, and we also label it so that the user knows what to put inside the plain text edit. Here is our paint event function, which is used to paint the components of the widget. First, we draw a green rectangle at the bottom with a height of 20, 20, which represents the floor. And then we draw an ellipse or a circle, which represents the ball, and we gave it a color blue. And we also drew some grid lines with an interval of 20 and also indexes to help us measure the bounce height of the ball. And here is a function to convert the input to from string to float. And here is our combo box, which basically allows us to choose what materials that we want to use with different COR values.
So next I'm gonna explain void animate. Um, in this section, as you can see in the right side of the slide, we apply gravity, which is 9.5, and also time interval 0.05. So by applying gravity, it will calculate how much the ball speed changes due to gravity within a small time interval. Next, we will also update the position, meaning that after we calculate the speed, the ball position will change as it is moving downward. Next, there is ground collision check. Uh, it will so in this section, it will check if the ball has touches the ground or not. If it has, then the code will simulate how the ball bounces back, and it will calculate the height of the ball drop and then adjust the speed using COR to simulate the bounce. And then there will also be position adjustment. So to prevent the ball from going through the ground, then the code will adjust the position to right above the ground level. And lastly, there's visual update, meaning that it will triggers an update to redraw the ball's position on the screen, and it will create the visual effect of the ball's movement and bouncing. Next, I'm going to explain voice change underscore material. So this just basically means that because there we use different type of material, then there will be different type of COR. At the right side of the slide, there is COR text. So this code will first read the file by open file, and then the code will read the file, and then it will extract the COR and then convert string to double. And lastly, we also did error handling to prevent if there are any error to happen. So if there are any error that happen, then the code will debug. And then next, there is main function. In the main function, it basically creates the size of the window, which is 600 times 600 pixel, and then the window title, and then it will start the application's event processing loop. Um, Here we can see the functionality. So the user can control the radius, initial height, and initial velocity, and also the type of material of the ball. And then the user can press start, stop, reset, or exit. So we uses 14 different material. If you start, then the program will start. And then if the user chooses to stop the program to re-enter the value, and they can use stop and then click reset. Okay, next, there are some difficulties that we face in the making of this project, and we've illustrated in the video below. So when we start the program, so the ball falls right through the ground, which is actually impossible. And to resolve this problem, we managed to solve it by using an argument, which is height minus position equals to height. And this code will prevent the ball from going through the floor again. So in conclusion, our project demonstrates a simple bouncing ball animation using Qt. It provides a simulation of basic physics concept of the bouncing ball and the material properties of the ball's behavior. That's our presentation. Thank you for listening.